As the next step, we're gonna set up the budget tracking worksheet, and this is where we're gonna keep track of our actual income, expenses, and savings allocations. And the budget planning worksheet that we have just set up provides a crucial input for this budget tracking sheet in the form of the defined custom categories, which we're now gonna use to accurately categorize each of the actual transactions. And we're gonna track these actual transactions in an input table. So let's start by defining the table column headers as date, type, category, amount, and details. Then we select those 5 cells, press Ctrl T to insert a table, and set a check mark for My Table Has Headers. Let's enlarge this table to get a better view of the overall table design and also increase the size of those columns. As the current table style doesn't meet our expectations, let's again create a custom table style. And we're gonna start with a duplicate of the savings table style. For the name, we're gonna go with tracking table style. And for the whole table element, we then adjust the border setup by removing those in-between borders. Only for the header row, we're gonna add all horizontal and vertical borders in there. And for the fill, we select this dark blue. For this table style in particular, we want to add one additional element, which is the first row stripe, for which we set the fill color to this light gray. And as you see, the first and second row stripe basically allow you to define alternating fill colors for the table content rows, and for a transaction tracking table like this seems to be an appropriate design. Let's apply this new table style, and then take care of the general text formatting in the table. For the header bar, we want the text to be aligned to the middle and the left, but with a small indent. And for the table entries, we're gonna decrease the general font size to 10, align it to the left, and also add a small indent. After that, let's start setting up the input columns, starting with the date column. Technically, you can enter dates in any form you want. So for example in this clean and readable format, but also month/day/year. And whenever you enter a value into the cell right below the table will automatically be expanded to now include that row and applies the defined text formatting. As we want to have all dates being displayed in a uniform format, independently from which format they have been entered in, we're gonna define a custom and clean date format like this. In addition, we want to add a data validation to this column to ensure that only date values will be accepted as input. For the validation criteria, we can select to only allow dates. And as we want to allow basically any date, let's set this to greater than the smallest available date in Excel, which is the 1st of January 1900. In case a value is entered that doesn't match this validation criterion, we want to show a custom error alert that simply tells you what you have done wrong. Let's confirm this and put it to the test. When we enter a valid date, everything is fine. And when we enter a non-accepted value like a text for example, Excel will not accept that value and shows our custom error alert. Perfect. The type column is where we're going to choose if the entry is of the type income, expenses, or savings. For the best user experience, let's create a drop-down list that contains those 3 options. So with the table column selected, we open the data validation window. And to get a drop-down list, we have to allow a list of values. And you see by default, the in-cell drop-down option is already activated. Then in the source field, we can type in our 3 items separated by a comma, And as you might see, the values we type in exactly match the names of the 3 category tables that we have defined in the budget planning sheet. And that is crucial. Even with this drop-down option activated, you can still simply type in values into those cells. And when someone types in a value that is not in the list, we want to show a custom error alert that points to the fact that only values from the list are allowed. Let's click OK and test it for the first record. As you see, we have all 3 options available, and when we select a value, it will be written directly into the cell. And whenever we type in a value into the cell that is in the list, it will be accepted just as fine. But as soon as we type in something slightly different that's not defined in the list, the error alert is triggered and the input value gets rejected. The category input column is where we now gonna dynamically inject the custom categories that we have defined in our budget planning worksheet. In this column, we want to have a drop-down list that, depending on which type has been selected in the type column, offers all the custom categories of that type that we have previously defined. Now in the source field, we're gonna insert a formula that will make this a dependent drop-down list. Since the values that we can select in the type column perfectly equal the table names that we have set up for the 3 category tables in the budget planning worksheet, we can now apply the indirect function to convert this simple text value from the type column into an actual reference to the respective table content. To make this work row by row, we have to make sure that this is a relative cell reference without any $signs. And in case a value is manually typed into the cell that is not contained in the respective category table, we also want to show a custom alert similar to the one that we have defined for the type column. Great! Let's take a look at the first row, and as you see, since we have selected income for the type, the category dropdown automatically contains all the defined categories from the income category table. Let's select a value and increase the size of that column so that all the categories will be displayed in full length. With expenses selected as type, the category dropdown now contains all the defined expense categories, and eventually, for the savings type, we get all the defined categories from the savings category table. That is already pretty amazing, and it ensures that later in the dashboard, the budget plan and track values can be perfectly matched together. One drawback of drop-down lists in Excel is that once a value has passed the data validation and is written into the cell, the data validation will not be repeated anymore when the underlying list of allowed values changes. If we, for example, change the type to expenses for this first record, this updates the available drop-down list to now show all the expenses categories, but it doesn't affect the value that is already written into the cell, as long as we don't actively override it with a value from the updated list. The same is the case if we would delete or rename a category in the budget planning sheet. There is no automatic indication that the value that is already written in there might be outdated and needs to be replaced. So to solve this issue, I want to add a conditional formatting rule to this category column that checks if we get an NA error, which basically means no such value found, when we try to look up the category value in the category table that has the same name as the selected type. For the lookup, we use the match function and provide the category value as the lookup value. Then a reference to the relevant category table as the lookup array, and as the final argument a 0, which means it has to be an exact match. Now, if that category value written into the cell right now is not found in the category table of the selected type, the match function will return an NA error, and thus the isNA function would return true. In that case, we want to set the font color to a warning red, indicating that the category value is no longer part of the relevant category list and probably needs to be replaced with another category. And as you see, the first records category is now colored in red, as employment is not found in the list of defined expense categories. However, once we change the type back to income, the red color disappears as now both the type and category fit together again. This is just a clean and user-friendly way to ensure the consistency of type and category in this worksheet at any time. The next column is the amount column, where we're going to input the actual value of the transaction. So let's start by entering some example values so that we can properly set up the number formatting. And as the general number format, we're going to apply the accounting format, but with 0 decimal places. Of course, you're always free to display the 2 decimal places if you prefer it that way, but without the decimal places, the focus is more on the actually relevant digits before the comma. Just like for the other columns, we also want to apply data validation to ensure that only valid values, in this case only numbers, can be entered into this column. The only suitable option from this allow section would be decimals, but since we don't want to specify any further conditions for the value range, we're gonna choose custom instead and enter the isNumber formula. And inside that function, we're gonna reference the first cell as a relative reference without any $signs. This will absolutely do the job for us, and in case this formula returns false for an input value because it is not a number, we want the error alert to show an appropriate custom message. Once we confirm this data validation setup, you see that entering valid numbers is accepted, while entering something else, like text for example, will trigger this custom error message and reject the entered value correctly. For an improved user experience, we also want to visually differentiate between incoming amounts from income and allocated amounts to either expenses or savings. For the allocated amounts, the default number formatting aligned to the right is absolutely fine. But for the incoming amounts, we want the value to be aligned to the left and colored in green. And the way we're going to do this, you've guessed it right, is by adding another conditional formatting rule to this column, which checks if the type value in the same row equals income. Again, make sure to make the cell reference relative without any $signs, so that the rule is correctly applied in each row. And if that condition is true, let's set the font to a green color and a bold style, and then change the number format to the number category. And make it look exactly like the custom accounting format that we have defined as the default, so with 0 decimal places, a comma as a thousand separator, and brackets instead of minus for negative numbers. Once we confirm, we see how this impacts the values in the amount column just as intended. The reason why the values are aligned to different sides is that the general number format follows the general left alignment setting that we have applied to the whole table in the beginning, while the accounting format is always automatically aligned to the right. The last input column is the details column, where we can enter any relevant details for each record. Let's increase the size of that column and format the potential text input to have a dark gray color. While some records are already pretty self-explanatory, a good example for a record that would definitely benefit from providing additional details is expenses for clothing. Here it would make sense to specify what did you buy and where, so that at a later point of time you are still able to understand what that tracked transaction was about. For the further development of this template, however, it is not necessary to have any data in the details column, so we're gonna leave it empty during development. When applied for tracking your own budget though, I definitely recommend to provide details for all the records if possible. After we have successfully set up the 5 input columns, let's add an additional column to automatically calculate the balance at each point of time. As we want to make this calculation fully robust against any sorting or filtering in that table, we're not gonna rely on the order of these records, but instead gonna sum up over all the records of the same or an earlier date, no matter where they are located in the table. The target value column over which we want to sum up, of course, is the amount column. And for summing up values from a value column that meet certain conditions in other columns, a common function to use is the sum product function, in which we can simply pass the target value column as the first array and then provide conditional arrays based on other columns to filter out only the relevant amounts. For the first conditional array, let's open a bracket and check for each row in the date column which of those dates are smaller than or equal to the date value of the record for which we want to calculate the balance. You can perfectly see that from within the table you can reference whole columns as the column name in squared brackets and the record of a column in the same row with an additional @ symbol. This conditional statement will return an array with either a true or false value for every row of the table, and is then multiplied with the amount array and summed up through the sum product function. However, when we now close the statement and hit enter, we see that the resulting sum for every row is 0. So it seems like that conditional statement doesn't work properly right now. The reason for that is simple, because within the sum product function, if you put in an array that returns Boolean true or false values, you have to either multiply it with 1, so that you get ones and zeros, and now the sum is correctly built as you see, or alternatively, you can tell the sum product function that this is a conditional array that returns Boolean values by adding 2 dashes as a prefix. That has the exact same effect. Right now, this statement isn't fully complete, as we are simply adding up the amounts from dates equal or smaller than the date of the record, no matter if they are income, which would positively impact the balance, or an allocation to expenses and savings, which actually should negatively impact the balance. As we prefer to not be forced to negate the values when we enter them into the amounts column, we somehow need to handle that in the balance formula. And the way we can do this is by adding another conditional array to the sum product statement. What we want to generate is an array that returns a -1 in case the record is not of the type income, and a 1 in case it is of the type income. So let's open a bracket and start by checking for each row if the type column value is unequal income, so it's either of the type expenses or savings. This will return true only for the expenses and savings rows, and therefore we can multiply that with -1 to get an array that has either a 0 for income entries and a -1 for expenses and savings entries. We still need to turn that 0 for income entries into a 1, because otherwise all the income entries would be ignored, and for that we can simply add up this first part with a second statement that checks if the type equals income, which then will return a 1 for income entries and a 0 for all the other types. So both these statements added up together produces an array of either 1s for income and -1s for expenses and savings. Once we hit enter, you'll see that the balance is now correctly calculated, as income values positively contribute to the balance, while allocations to expenses or savings make the balance go down. Eventually, let's apply the same number format to the column as for the amount column. And to show you that this balance calculation is fully robust against any sorting or filtering in the table, let's filter down to the expenses only and resort from highest to lowest date. As you see, the balance for each record stays the same, which is pretty amazing. In addition to the balance column, we're gonna add one additional calculated column that we're gonna call effective date. Let's quickly give both these columns a slightly different design to make them visually differentiate from the input columns. A light gray background for the header and a dark gray font color for the whole column seem to be a good choice here. Now, the effective date column will allow us to implement a feature that solves a big real-life issue for many people when tracking their budget, and that is late monthly income. Because for many people it is the reality that they get their paycheck or earnings towards the end of the month, and instead of considering that as income for that month, which would then make up for all the previous expenses and savings of that same month, it makes far more sense to consider this as the disposable income for the next month, because logically you want to first earn the money before you spend it or save it, and not the other way around. Now, with the current setup, if you track income with a date towards the end of a month, later in the dashboard it still would be considered as the disposable income for that month in which you have received it, instead of the next month, which would make far more sense. And now, as a workaround, you could decide to artificially enter the first day of the next month as a date, even though that is not the actual date on which you have received that income. But why not simply building a feature that does this automatically for you if you activate it? To let you decide if you want to activate that feature and on which day of the month you want to start assigning received income to the next month, let's jump to the settings worksheet and create a new section. We're gonna call that section Budget Tracking and Dashboard, as the settings are only specifically for those two worksheets. And then we're gonna insert 2 rows in here so that we have some space to create a title for that feature that we call Late Monthly Income. The first element here will be a drop-down field to decide if we want to activate or deactivate that shift of the late income to the next month. And as this drop-down field is one of multiple sub-elements below that title, we're gonna add a small indent to the label. To create a drop-down list, let's select the input field, go to the Data tab, and open the Data Validation window. We're gonna allow a list that has 2 values, which are active and inactive. Let's select active for now, and then we're gonna expand the whole section area to get more space for the settings of this and other features by selecting a range containing the bottom row and multiple rows below. Then we open the advanced border settings, set the border color to this midlight gray, and to remove the current bottom border, all we need to do is click twice on this middle horizontal border until no border is visible, and then add a new bottom border and the right and left borders for the whole selected range. Great! For the second input field, let's copy down this label and slightly reduce the size of the separator row. In this input field, we want to set the day in a month starting from which we want to consider received income as the disposable income for the next month. Let's resize this column to make the label fit in. And then we can leave the input field as is and only gonna insert a value that somehow makes sense, like day 20 in a month. To access the value of these settings fields, let's define the global name for that first cell as Shift Late Income Status, and the second field as Shift Late Income Starting Day. Also, let's not forget to add a small description for those settings. For that, we can merge these 3 cells together, align the text to the top and left, and then enter the description text. To make the text better fit in, we're gonna resize the column and also activate the Wrap Text option for automatic line breaks. Once we have finished that description, there is only one thing I want to do here to improve the general user experience, and that is graying out the second field whenever the Shift Late Income field is set to inactive, because that then indicates that you first need to activate that option before the value of the second field will have any impact. Setting this up is quite simple. With the second field selected, we only need to create a new conditional formatting rule that checks if the Shift Late Income status equals inactive. And if that is the case, we set the font color to this midlight gray and the cell fill to this light gray. Let's confirm that, and now you see, once we set this feature to inactive, the second field is grayed out, and we as a user immediately understand we first need to activate that feature before the value of the second field will have any impact. With those settings set up, let's jump over to the budget tracking sheet again and create the formula for the effective date column. The Shift Late Income feature should be applied if multiple conditions are met, which are the type has to be income, the Shift Late Income status has to be active, and finally, of course, the day in month of that records date has to be greater equal the defined Shift Late Income starting day. If all those conditions are fulfilled, then the effective date is set to a new date for which the month is the month of the date plus 1, and the day is the first of that month. And if any of those conditions are not fulfilled, then the effective date will simply equal the date of that record. Let's set the number format for this cell to the custom date format we have already used for the normal date column. And since the Shift Late Income feature is currently active, and we have set the starting day for that feature to the 20th of each month, this income record right here should keep its effective date as the 1st of January, even if that income is actually received a few days earlier, let's say on the 27th of the previous month. As you see, the effective date column automatically shifts the date of that income to the next month, but only as long as the day in month is at least 20. So if we change that to 19, for example, you see the effective date is no longer shifted to the next month, just as intended. And a day in month greater than 20 again will make the feature go back to work. As this feature, if activated, is expected to be applied only to a small portion of all the records, and all other effective dates basically are equal to the entered date, and for that reason provide no new information, let's set the default font color to this lighter gray and only make those effective dates stand out for which the date has actually been shifted to the next month. To do this, we're gonna add a conditional formatting rule to this column that checks for exactly those 3 conditions. So let's copy them from the formula, select the whole column, open the Conditional Formatting Rules Manager, and create a new rule. For the formula, we're gonna paste this AND statement that we have just copied, and since conditional formatting rules cannot handle those table-specific references, we're simply gonna replace that with a normal relative cell reference to the type value for this first condition, and the same for the date value in this third condition. And the rest can stay as is. Now, whenever those conditions are fulfilled, which means the date is shifted to the first day of the next month, we want to set the font color to this dark gray. And for the date format, we're gonna do something really cool. We define the same custom date format as we have already done before, but to also indicate that this date has been shifted, we can insert a Unicode symbol like this arrow as a prefix. Please be aware that this symbol is not part of the cell value, so the cell value itself is still just a date. And that is pretty amazing if you ask me, because now you can see within a second to which records this feature has been applied. Let's quickly deactivate that feature. As you see, now the effective date column is just a perfect replica of the date column itself. And when we activate it again, it works beautifully. With this, we have finished the work on that tracking table. Now we also want to access the information in that table from the outside. And for that, we first need to make sure that the table content is accessible through an appropriate name reference. So let's go to the Formulas tab and open the Name Manager. When we scroll down here, we see the table as Table 4 at the bottom, and we're gonna change that name to tracking. Now, when we select the whole table content, you can see the name of the table up there in the name bar. The first occasion for which you want to access that table is the creation of some informational tiles on top of the table that display the current date, the date of the last record, the number of records, and the total tracking balance based on the latest record. To generate those information, let's jump over to the calculations worksheet in which we're going to put in all the background calculation for this template, so also the calculations for the dashboard later. For a clean setup, let's create a simple header by merging these 4 cells, setting the fill to this dark blue and the text font to white, size 9, and aligned to the left and middle with a small indent. And then we're gonna specify that all the calculations below are for the budget tracking worksheet. As the first value, we want to calculate today, so the current date, which technically is quite easy using the today function, but as the current date will be used in many other formulas in this template, and during the development of the template we want to be able to simulate the current date to be a specific date in the year, let's create a new name, current date, that we can set to whatever date we like during development, like for example the 15th of March of 2022, and once we have finished the development and go into the production mode, which means we start actually using the template, we can replace this with the today function to make it fully dynamic. So from now on, be aware to always use this current date name instead of the today function whenever required in a formula. As these calculations for the budget tracking sheet are for the informational tiles, and we will link these values from the calculation sheet into some text boxes, it is crucial that we format those values here in the cell exactly how we want them to be displayed in those tiles. So for this value, we apply our usual custom date format. Then as the next value, we want to calculate the date of the last record in our tracking table, which can be calculated as the maximum of the tracking table's date column. Let's copy over the date format from the cell above, and based on these two dates we now want to calculate how many days are between the current date and the date of the last record. For that we use the days function, which expects 2 inputs. First, the end date, for which we're gonna pass the today value, and the start date, for which we pass the last record value. This returns 70 days. As we want to display this piece of information as a short text in brackets behind the date of the last record, let's add an if statement to first check if the last record equals 0, which would be the case if the tracking table has no records at all, and in that case we simply return an empty text string, and in case the date of the last record is not 0, then we're gonna return the calculated value in brackets supplemented with the words days ago. So we get this composed text component. For the next tile, we want to apply the number of records in the table, which can be easily done by applying the count function to almost any column in the table. We're going to take the date column here. This will give us 4. And as an additional information in that tile, we also want to display the number of records in the current year, because assuming that you're going to use the template over multiple years, that is a valuable information. In our sample data, for example, one of those records is from last year, so this calculation is expected to return 3 for this specific setup of records. Here again we can make use of the sum product function, and this time we only pass one conditional array, that returns 1 for all the rows for which the year of the date in the date column equals the year of the current date, and a 0 for the others, at least if we mark this as a conditional array. So those values in the returned array summed up will yield the value 3 just as expected. And just like for the delta last record, we're gonna transform this into a full text string with this information in brackets and supplement it with the words this year. Great! For the last tile in the budget tracking worksheet, we want to display the total tracking balance, which basically is the balance value of the record with the latest date. As we have already calculated the date of the latest record, we can create an index match statement to look up the respective balance value. For those of you unfamiliar with index match, the index function returns the value of an array at a given position. So since we want to return a value from the balance column of the tracking table, let's select this as our return array, and then to figure out the correct row number within this array, we use the match function, which looks up a value, in our case the date of the last record, in a lookup array, in our case the date column of the tracking table, as an exact match, and then returns the row number of the match, which we can then use as the row number in the index function. And as you see, it has returned the correct balance of the latest record. In case the tracking table has no records, this match statement would cause an NA error, so no worries, we're gonna catch that error using the ifNA function and return a simple dash in that case. And eventually, let's format this balance value as an accounting number with 0 decimal places. And as the final calculation for this last tile, we want to generate a short balance analysis text that, depending on whether the balance is positive or negative, displays a different content. So if the balance value is greater equals 0, we want to display behind the balance value of tracked income left to be allocated. And in case the balance value is negative, we want to display that amount X that has been allocated is not covered by income. Let's adjust the column size to make this fit in. And since now all the calculations for the tiles are prepared, let's jump over to the budget tracking worksheet and create those tile elements. To create a clean and good looking tile, let's insert a rounded rectangle like this, slightly adjust the size, and then position it in a way that it is aligned with the left border of the tracking table. Then we right-click on it and open the Format Shape area, in which we can now set the fill color to white and the line to this lighter gray and a width of 0.5. We can play around with the roundness as well, and for those tiles in particular I prefer a bit of roundness, but not too much. To make the tile better stand out from the white background, we're gonna add some light shadow with a high level of transparency like 85%, a reduced size of 95%, a strong blur of 65 pt, then we leave the angle at 90 degrees and increase the distance to 10 pt. That results in this beautiful tile background that is not super dominant but stands out through its neat design. Of course, this first tile needs some content, which will be the date of today. So let's start with a title for which we insert a text box and enter the tile's name. By default, a text box has a fill and border, and we want to have neither of them. So let's set this to no fill and no line. In addition, we're gonna make this text bold and then move it to a good position in the upper left corner of the tile. For the date value, we can just duplicate that text box, and since we now want to dynamically reference the calculation we have set up in the calculations worksheet, we go to the formula bar with the text box selected and enter equals, and then jump over to the calculations sheet and select the correct cell. Once we hit enter, this value from the cell is now visible in the text box and will update anytime the calculation result in the background changes. What you need to know about linking text boxes to cells: whenever you create or update such a cell reference for a text box, Excel for some reason resets the text formatting, and in this case the bold style has been removed. So keep that in mind. For this value text now, we want to increase the font size to 12 and also make it bold. After that, let's align the title and value text box to the left and do some final adjustments to the positions of both these text boxes until it looks good to us. Once we are happy with the result, let's select all those elements, go to the Size and Properties tab on the right, and under Properties select the option Don't Move or Size with Cells, so that whenever any of those columns are resized, the proportions of those tile elements stay unaffected. Great! With these tile elements selected, let's create a copy and start building the second tile for the date of the last record. For this tile we need to adjust the size of the text box to make it fit in here, and since the content will also be a bit larger, let's resize the tile size as well. Since we know that in the calculation sheet the date of the last record is calculated in the cell right below the current date, we can just change that row number in the cell reference to 9. And there we have the calculated date. But again, as I just told you, the text format is reset and we have to change it back to a font size of 12 and a bold style. Since we want to add the additional information of the delta between the current date and the last record, let's make this text box a bit smaller and then duplicate it. The delta text content is calculated in one cell below the date of the last record, so let's simply change the row to 10, and there we have the dynamic text statement. For all secondary information in a tile, we want to make the font size a bit smaller, and for that reason we set it to 10.5. And then we're gonna position it right behind the date, and do some final adjustments to the tile size. Wonderful! We can now use this as the blueprint for the third tile that will display the number of records and will also have one main value text box and a text box with some secondary information. Let's call this tile Number of Tracked Records. Change the reference to E11, which then returns a number of 4 total records in the tracking table. Again, we set the font size to 12 and make it bold. For the second text box, we change the reference to E12, which then returns the text statement on how many records are in this year. And here we readjust the font size back to 10.5. As the number of records won't take as much space as the dates, we can reduce the size of this text box and move that one over to the left. Maybe make this one even smaller. And it looks like the secondary information text box should be moved down a tiny bit for a better alignment. So let's move this one down a tiny bit as well. And finally, we're gonna adjust the size of the tile and select all those tile elements to create another copy for the last tile in this worksheet. This last tile will be displaying the total tracking balance, which is found in cell E13 of the calculations worksheet. Let's set this text font to 12 and bold again. And for the secondary information text box, which probably will require a bit more space than in the previous tiles, we're gonna start by moving it to the right, change the cell reference to E14, then readjust the font size to 10.5, and that looks pretty good to me. Let's quickly test if the size and position of both these text boxes is still appropriate once the balance changes. For a smaller balance, it still looks okay. For a bigger negative balance, however, the value text box seems to be too small, so let's make it a bit larger. And maybe also move that secondary text box a tiny bit to the right. And adjust the size of the tile. Perfect. That's already it for the setup of those single tiles. Now we only need to get those 4 tile components perfectly aligned. And to do this, let's transform each of them into a group element. And select all 4 groups. Go to the Shape Format tab, and then align them to the middle. To unify the spacings between the tiles, let's move the second tile and also the last tile a tiny bit to the right. And with this, we have completed the setup of this budget tracking worksheet and can now move on to bring it all together in the budget dashboard. For the dashboard, we're gonna start with the initial dashboard setup. And for this initial setup, we start by creating the header bars for the breakdown and chart section. So let's select range C11 to X11. And those first columns from column C to column X will be used as in-sheet calculation columns right in front of the visible budget breakdown section. So those columns will be hidden later, but nonetheless they will get a clean blue header bar and, more importantly, a light gray subheader bar right below where we're going to insert the individual calculation column names. Then the visible budget breakdown section starts in column Y and covers a total of 6 columns. As for this section header, we want to have one centered section title. Let's merge these cells together, align the text to the middle, set the fill to this dark blue, and eventually the text font to white, size 10, and bold. Let's insert breakdown as the section title. And for now we can hide those in-sheet calculation columns to further set up the visible part of the worksheet. For the chart section header, let's select the range from AF11 to AR11, merge those cells together, and apply the same formatting as for the breakdown section header. And as the section title, we're gonna insert Summary. One fundamental key of this dashboard will be the option to select exactly which year and which period within that year you want to see as a user. And for that, we're gonna need 2 drop-down lists that we're gonna set up in the top right corner. For the drop-down header, let's merge these 2 cells together, align the text to the middle, and make it bold. And then we open the border settings, select this mid-light gray as color, and create this light border around this range to visually separate it from the surrounding area. The title of this first drop-down selection will be simply Year. And then we select the 2 cells right below, merge them together as well, align the text to the middle, reduce the text size to 10, and set the fill color to this light green. This is where we want to put in the drop-down selection for the year, and to make this fully obvious, let's add a small descriptive text to this 3-cell range on the left, which we also merge, then insert the instructional text, And to make this visually less dominant, we're gonna reduce the font size to 9, change the font color to this darker gray, and in order to position it a bit closer to the drop-down field, let's align it to the left and add a small indent. And finally, we're gonna add an italic style. For the period drop-down selection, we can then just copy over this range, change the title to period, and adjust the instructional text. Great! As the next step, let's build up the lists for those drop-down selections, and as these lists will have a lot of potential values that are partly dynamic, let's set them up on a separate worksheet for those drop-down data. For the year drop-down, let's create a header with a bold font style, a dark blue fill, and a white font color. And right below, we're gonna define all potential values for the drop-down selection, for which we slightly decrease the font size and also make them aligned to the middle and center. The first selectable value in that list is not a year number directly, but instead a text that says current year. And the idea behind this is that whenever this value is selected, this will be translated into the current year number in the background calculations, which we're gonna cover in a minute. Then all the subsequent values are the 10-year numbers dynamically dependent on the starting date that is defined in the settings. So just like in the budget planning sheet, the first year is the starting year, and all the subsequent years are the previous year plus 1. For a clean design, let's add some borders around that list by opening the Advanced Border menu, selecting that mid-light gray as color, and adding a bottom, left, and right border to that range. That looks great. So let's just copy over the header for the period drop-down data, and for these values we also want to slightly reduce the font size and align them to the middle and center. The period dropdown works under the assumption that the specific year is selected in the year dropdown, and now we need to decide whether we want to take a look at all the months of that year by selecting total year or a specific single month. As a specific month, you can either select the current month, which just like in the current year option will be dynamically translated into the current month number in the background, or directly one of the 12 months in a year. To save us a few steps, we're not going to type in all the 12 months as text here. Instead, we simply define them as full dates, for which the day and year basically don't matter, so we just set them to the first day in the month and 00 as the year. And now what we can do for all those 12 dates is define a custom date format that simply is M 4 times. This date format displays these dates as the full month name and nothing else. And what is amazing about this setup is that we can now display these values as the full month name in the dropdown selection, and at the same time we can extract the month number from the selected value simply by applying the month function. So let's add some borders around that range, just like we did for the other list. And now all we need to do on the dashboard sheet is to select the drop-down cell, open the data validation window, select list, and reference the defined list in the source field. So now we have all those year values available in this drop-down selection. And then we gotta do the same for the period dropdown. Select list as the data validation method, reference the defined period drop-down list, and now all these values are available in this drop-down selection. The only adjustment that we need to do is defining the same date format for that cell, so that once selected, the underlying date is not displayed as this big number, but as the respective month with its full name. That works perfectly. And just as a quick preview, to always have the latest month selected at any point of time, the dynamic combination of current year and current month will do the job for you, because that is the logic that we're gonna implement right now. To make sense out of and interpret these selected drop-down values for all other upcoming formulas that we're gonna build in this template, let's create a new section for the budget dashboard worksheet and define two new calculations that we call selected year and selected period. For the selected year, we want to return a year number for every drop-down selection, while for the selected period, we want to either return the total year expression or a month number. Let's start with the selected year calculation, for which we're gonna take a look at what has been selected in this drop-down cell. Since this is a merged range, it gives us the whole range, but we only need the first of these cells. And we first check if that value equals current year, because if that's the case, we want to return the year of the current date. For all other potential values from this drop-down list, we know that these are year numbers. So if the value is not current year, we just pass through the cell value. To make this interpreted variant of the selected year easily accessible for all the future formulas in this template, let's give this cell the global name selected year. In the dashboard sheet, we can then do a quick test by referencing that name next to the drop-down field. With the current year selected, 2022 is the correctly derived year value, and for all the explicit year values, the value is just passed through as intended. Perfect. To also derive the correct values from the period drop-down selection, we first check if the selected value equals total year. Because that is the only value from that drop-down that we basically gonna leave as it is. In case the selected value equals current month, we're gonna return the month number of the current date using the month function. And since we know that all the other potential values from that drop-down list are explicit dates from which we want to extract the month number, we're gonna apply the month function to the selected value directly in case the first two conditions are not met. Let's close that statement and make that calculation result available as selected period. Just like for the year, we can test the functionality of that one by referencing that name next to the period drop-down field. With the current month selected, it correctly returns 3, as we have set the current date to the 15th of March. When we change that value to total year is just passed through to the selected period value. And for all explicitly defined months, the corresponding month number is perfectly extracted from the underlying dates. That is great. As these two calculations are, sort of special as they are the direct interpreters for the drop-down selections in the dashboard, let's delimit them from all the following calculations by adding a bottom border in this mid-light gray with a dotted style. Now, whenever we want to display the selected year and period somewhere in the dashboard, for example the section headers, we can display the selected year value directly. But for the selected period, it would be prettier to display the month's name instead of the extracted month's number whenever current month or a specific month is selected. So let's create a version of that selected period value that is more suitable for presentation in headers and titles, that we're going to call selected period display. And in the formula, we first check if selected period equals total year, in which case we again want to just use that value here as well. And in all other cases, we know that selected period is a month number. So we're going to transform that month number into the corresponding month name as a text string by using the text function, putting in a compose date for which the year and the day both really don't matter. It's only important that the selected period value is used as the month input, because we want to print out that full month's name using the MMMM date format. Let's hit enter, and you see the month number from selected period is now available as an easy to read text string version, which we're going to make accessible as selected period display. As the final step for this initial dashboard setup, let's make the selected year and period part of these two section headers. So we're going to make this a composed text string starting with breakdown and a dash. And then in case the selected period equals total year, we're going to print out the selected year and then the total year in brackets. Otherwise, we first print out the selected period display value, which then has to be a month's name, and then after adding in a space, the selected year. So with the current year and current month selected, the section header now correctly displays March 2022. When we select an explicit month, the month and the year are displayed in the same way. And whenever we select total year, the year is printed with total year following in brackets. And of course, when selecting another year up there, the section header updates as intended as well. Eventually, let's copy that formula over to the summary section header. We only need to replace the breakdown with summary, and that's it.